Curvature theorem. When we curve a straight line and form an arc, each and every point, non-consecutive, of this line is now closer to each other inside the arc, and therefore this particular approximation differential between each and every of its points will also influence the total of the set or line, which must have lost a minimum of dimension. And vice versa, if we stretch an arc until it becomes a straight line, now all its points are further away from each other, and therefore the set or line will also be more extended and dimensioned. This, taken to the infinite extreme, could be considered that if we rolled a line indefinitely, it would disappear at a single point on the plane. For this reason and property, when we add sides of triangles inscribed to the circumference to obtain pi, and also the sum in series form, what we get is a straight line, extended arc. The sum of many straight lines is also a straight line, which must exceed, even minimally, the correct value of pi. As for cyclic pi, YouTube video, cyclic pi 6, its mathematical and geometric properties are so important that it represents a special number of pi in itself, even if it were not the correct pi. Although from my point of view, and precisely because of its properties, it must be the correct number pi. There are many ways and means of extracting the cyclic pi from the geometric figures inscribed or relative to the circumference, through simple and direct formulas, from radius, diameter, inscribed and circumscribed squares, etc., but here we are going to put three simple, easy, and differentiate paths. And they are, that of the special circumference of pi diameter, of the floating point method, and through the golden ratio or phi number. 1. The special circumference of pi diameter is the only circumference for any unit of measurement which complies with the fact that its diameter is pi, its perimeter is pi squared, and which produces or engenders an interior circle of perimeter 2 pi and radius 1, and a circumscribed square of perimeter 8. Well, the cyclic pi number is extracted from the interrelation of these parameters. 2. The floating point method is interesting because with its way of use the cyclic pi is easily extracted. This is done by raising cyclic pi to successive powers, and expressing its results in floating point. As we see when we get to the 17th power, the floating point result is 2 by square root of 2. But if we now proceed from here in reverse, from 2 square root of 2, we obtain the cyclic number pi. 3. With the use of the phi number, we obtain an interrelation formula between pi and phi, with which we can extract one from the other. Besides and following, we will include a property that I believe is important to justify the cyclic pi, and it is the circumscription property of simple geometric figures, in which powers and functions of basic elements will give us the measures of all their circumscribed figures. Then, allow me to explain in a simplified way the property of circumscription of geometric figures, in this case referring to the circumference and its inscribed and circumscribed squares. This property would tell us that powers of the basic elements of the circle, such as its diameter and the number pi, cycles of pi, will give us the dimensions of all the squares and circumscribed circles between them to infinity, as shown in this drawing and in the following one, in which we see that the current pi does not comply with this property, and deviates in successive powers. Finally, in this drawing, we see an analysis of the concept of line, very simplified, using giant points with which we can measure and adjust that the loss of dimension in the curves is real. The point, according to my model of dimensional geometry, the point would be the minimum possible expression of space, that is, an infinitesimal of space, devoid of length. Length, it would be the union of consecutive points joined together to form a line, which would be constructed simply by joining 2 points. With only 2 points joined together you can only form a straight line. To form curved lines we need at least 3 points. With 3 points, we can form a straight line or a curve. If we start from a straight line, to form a curve with 3 join points, we need to rotate the two ends about the center and towards the same direction, which will bring them closer together, and this approach will mean a very small decrease in length in the curved line regarding to the straight line. And vice versa, if we stretch a curve, the resulting straight line will acquire a very small increase in length. Well friends, thanks for your interest.